So I think we can start. Welcome everyone. My name is Mathieu. I'm a principal engineer for Red Hat. I should be on stage with Roberto as well, my friend and colleague, but he cannot make it today, so I will be alone in front of you to to talk about OS-Migrate. And in particular, the VMware to OpenStack migration with Ansible at scale. So before diving into the topic of OS-Migrate and the VMware migration, I wanted just to do a quick intro about the VMware migration with KVM because, well, unless you are living in a parallel world, this is a very hot topic since a few months or years, let's say. But this topic has been treated for many years now, and in particular thanks to the libstfs project, which is an open source project, and which has been created in 2009. So I pasted some few Google search about the blog post that you can find from, for example, 2010. Some YouTube video from VirdV2V or even some server fault questions. So this is a very old topic and it has been solved for years now. And yeah, I don't want to break dreams or whatever, but I won't say all migration tool, but almost all migration tools are using the libstfs tooling actually. So the VirdV2V in particular, which is a very great open source tool supporting a lot of operating systems. So that leads us to the question, because every tooling that you need is into the libsfs. So why another migration tool? So the first question. Sorry, it's. Sorry, not the first question. The first answer for us is. We have the experience of workload migration because OS-Migrate, so it's not a very known tool, but OS-Migrate has been created more than 5 years ago now. So we know how to do the pre-workload and the workload migration with OpenStack to OpenStack. So for us, in the, let's say, ideal world, half of the job is already done because we know how to import resources into OpenStack. So basically, we have to, let's say, change a little bit the source of the migration. And also the other great advantage is that OS-Migrate, it's a pure Ansible collection. So it's just about modules, roles, and playbooks, and that's it. So it's really, really easy to use, really customizable. There is no complex architecture to deploy. You don't have to deploy, for example, some API, some database, or whatever. This is just pure Ansible. And this is highly customizable. Pedro earlier today showed the integration with the Ansible automation platform. But so this is another way to use it. You can use also the CLI command, Ansible playbook. And the final and probably the most important things about my workload migration is the scalability and the way to handle very huge workloads. So just few words about OS-Migrate. So here I'm talking about OpenStack to OpenStack collections because we have two collections actually. So originality created for OpenStack to OpenStack migration. This is an Ansible collection. This is open source. The philosophy was to rely on the OpenStack APIs. So whatever OpenStack you have as a source or destination, I mean that doesn't necessarily be a Red Hat OpenStack, for example. It could be whatever OpenStack because we are talking only to the API. We don't have direct access to the nodes or even some agent. And yeah, this is made for pre-workload and workload migration. So I will define the term just after. But yeah, just about the architecture, I put a small quote here. Everything should be made as simple as possible, but not simpler. So I think that resume what is OS-Migrate. This is purely simple things. The only things you need, it's two Ansible hosts, and basically the default one is a local host in Ansible. So what we call the migrator host is a local host or whatever you want. It could be your laptop, it could be a container, it could be an Ansible execution environment as well. And then we need just a conversion host, which is basically just an OpenStack instance from where the core of the migration will be operated. So the copy of the data, the synchronization, and the conversions. Yeah, just few concepts about the migration, because I say the pre-workload migration. So for those who are not familiar with those terms, the pre-workload migration concerns all the resources around the virtual machine. So that means that it's, for example, flavors, security groups, networks, subnets, and OS-Migrate is exporting all those resources into serialized data, which is YAML file, and then import those serialized data to the destination cloud. So that means in the middle, you have the ability to modify if you want, for example, if you want to specify a specific network or just change the flavors or whatever, you can tweak your pre-workload migration like this. And this is the workload migration. So basically, the virtual machine is moving from one cloud to another. So yeah, let's talk a little bit about VMware, because it's quite different. As I said, OS-Migrate relies on OpenStack APIs. Indeed, with VMware, this is a really different ecosystem. There is two main things, is that the disk should be converted, because VMware disk cannot run under KVM. And the second one is that the cloud resources cannot be migrated out of the box. So you don't have this mechanism of pre-workload migration, but it's mainly what we call some mapping. So with the workflow, we have a discovery phase. This resource mapping, where we try to map, for example, we are extracting and gathering all the information from the vCenter and the virtual machines, and then we are mapping it to the resources available in the OpenStack destination cloud. Then there is a disk transfer and the conversion, and finally we are spawning the OpenStack instance. So this is basically the migration workflow. So we are able to run the migration from a live virtual machine. We are migrating from a snapshot, actually. And the data are moving via the conversion host to a Cinder volumes, and then we are spawning the virtual machine from the Cinder volumes. So we are using this great feature from VMware, which is the change block tracking. So for those who are not familiar with that, this is basically like a timestamp on the disk live, for example. And then you just have you don't have to each time copy the whole disk data, but you just have to copy the delta between two CBTID, which will save you a lot of time in particular. And I will show you a bit later in the slide, but in particular when you have very big disk, it's a very nice feature. So I'm sorry, Pedro, I stole your slide, but just I wanted to put this slide just to say that on top of this there is Ansible automation platform to automate and orchestrate OS-Migrate on top of that. So it's not only a CLI Ansible command CLI tool, but you can also get Ansible automation platform operate on the migration, and it's really a nice way, for example, to schedule, to act as a scheduler, but also to if you have different teams with different workloads, you can isolate their workloads and their specific migration jobs. Yeah. So what about scalability? So this is probably the main problematic when we are talking about workload migration, because okay, that's great. There is a lot of demo. and you can see, for example, 1 or 2 VM moving from VMware to OpenStack and with a great UI and everything. But actually, many customers just the main question are: I have X thousand of VM and X hundred of SXI node, and how many time does it will take to move from this to A to B? And so there is also this question, and also the maintenance windows generally is very tight, so they want to move it as soon as possible, the fastest way as possible, with the zero downtime and so on. So that's the biggest problematic we have to solve here. And so just about the downtime, so this is a common question that we have, but when you are moving from VMware to OpenStack, you will have a downtime during your migration, because the disk should be converted, so there is no way to not have the VM shutdown to, well, not the VM shutdown, but this time should be, there is a downtime. But on the other side, so we try to make our best, and we worked on two main ways, I would say. The first one is a parallelization of the migration. So we decided to work on that way, and also how to get the most stable, lightweight, and performant Ansible modules. So for the parallelization, so the conversion host can handle several migration in parallel. Each process are isolated and running in a specific PID. The only things you need is to stick to this small formula, which is 2 GB of RAM and 1 vCPU per process, and so per migration. So you have to scale your conversion host like this. Since you are following these rules, then you will be able to run XYZ migration in parallel. There is also another way that you can scale your conversion host as well. So you can run the migration with several conversion hosts, and this way is also nice with AEP. For example, when I said if you have few teams that have different workloads, you can assign to the teams a specific conversion host, and then they won't disrupt the other migration. And then, yeah, so for the Ansible module, the question was more how to make like the most performant Ansible modules, because the performance are really the cornerstone of all of this. And as you may know, Ansible is purely Python, and most of the Ansible modules that we have seen so far, it's written in Python, so that's great, but this is not the most performant language when we are talking about this specific topic. So the cool thing with Ansible module is that there is only 2 roles. It's widely open, and you have to stick to 2 roles. Just takes JSON as entry and gives JSON as output. So since you are following this rule, you can do whatever you want in the middle. So that means that you can use binary modules. So we decided to go with Golang language, in particular because there is the Gopher Cloud SDK package, which is supported and well maintained. And on the other side, there is a GovMomi VMware SDK. So yeah, we did the core of the migration with Golang modules, and so that was great. So the performance is really amazing compared to a Python module, for example. But there is some constraint that we figure out when we try to productize OS-Migrate. And for example, when we work with compile language, you face some Building issue. This is a classic, but you need to build for specific architecture, for example. So there is no hook in the Ansible Galaxy install to, for example, to build on the fly your modules. We also reached some collection size limit where we need to strip a lot the binary because Ansible doesn't expect to get some binary there. So yeah, we feel like a bit like a pioneer because again we didn't find so much documentation around that. So that's great because we did something maybe not new, but we are exploring something that is not common, and but we plan to contribute and help in that way. So I'm checking the timing. So the scan results. So I put some results that we've made in our lab. So indeed, the lab is let's say a perfect environment with on the same data center in almost the same rack and with a very nice network. But basically, for example, we got like 100 VM in less than 30 minutes. Which is so it was indeed some small VMs. It was not like very huge VM, but also the things that we tested is that if you scale the number of VM, the number of conversion hosts, and the number of process into the conversion host, how does the migration react, and if it's linear, or if the timing explodes and so it's pretty straightforward and pretty linear, and I think we should probably give thanks to to the libguestfs guy because, for example, the Virt v2v and dbkit server are really nice. And also the last, I put this 2 terabyte example, but we tested like 4 or 6 terabyte of data from a disk, and with the disk full at 9900%, and this is where the change block tracking feature is really useful because actually you can synchronize on the background your terabyte of the disk, and your VM is still running on the VMware side, and so you can iterate and do some synchronization, how many synchronization you want. Since you reach your maintenance window, and then you can just do the last delta sync, and so the migration with that, you can get a very small downtime even with a very huge disk. So that's a really interesting way to do the migration. We also work on some specific feature that allow you to move very huge workloads actually. We are supporting the fact that you connect one NFS server, for example, as a data store into the vCenter, and another one connected to the OpenStack, and then there is no data sync. There is just about the conversions because we can adopt those volume into Cinder. We support that migration path as well for OpenStack to OpenStack, and we get some great feedback for OpenStack to OpenStack with this mechanism. We can also consume an NFS mount into the conversion host and just consume the local disk, which avoid you, for example, you can prepare or move your storage and then do the conversion later. Yeah, I'm still on time. So basically, this is the feature of OS-Migrate. I think I already talked mostly about all of those. There is a YouTube video that you can find. It's probably the one that is at the boost, and yeah, that's it for me. And if you have any questions, I'm here. Yeah. You mean the last diagram? Yeah, basically this is we use Cinder Manage to adopt the volumes. So indeed, you need to get the storage compatible for VMware and for OpenStack as well. So this is not like something for OpenStack to OpenStack. This is easier because there is more. There is more common driver from source to cloud, source to destination. Sorry. For VMware, this is more about NFS NetApp, for example, which is probably the one supported by OpenStack, and the other one supported by VMware. Yeah. Well, actually, once you adopting the Cinder volumes, then it's just the data of the disk is into the Cinder volumes, but it's still under like let's say it's not convert to KVM. So you have to convert it to be able to spawn it in the with your instance. Yeah. Sorry, Nova. Sorry. Nova storage. What do you mean exactly? Yeah, I'm not sure what you. Actually, for example, the migration here is a bit like this is more about let's say volumes migration. So we are moving the data to Cinder. So and then this is a VM creation. So you know, I'm not sure if I answer your question, but. This is just the VM created in the OpenStack will be created with a Cinder volume attached. Yeah. So yeah, the term migration, actually this is a VM creation, not the migration is about the volumes. Any more questions? All right. Well, I'm on time, so thank you, everybody.